Hi everyone. There's one section left in this chapter, which is section 4.8 on functions and relations. So we'll be covering that over the next two videos, and then that will be the end of this chapter. So our goal is to decide whether a relation is a function and to be able to use function notation. So before we get into that, we need to talk about some vocabulary. So our first vocabulary term is relation. And when we talk about a relation, we just mean any set of ordered pairs. So that relation just tells us how x and y are related, just like it sounds. Now, a function is a specific type of relation, and a function is a relation where each input, and when we talk about input, we just mean our x values. So each input has exactly one output. And again, when we talk about output, we mean y values. So when we talk about functions in a little bit, we're looking for does each x value get matched with only one y value? So we'll get to that in a minute. So the first thing really what we're going to look at is identifying the domain and range from ordered pairs. Now when we talk about domain, this is all of the x values. And range is all of our y values. So if I look at example 1, they give me this relation G. Remember, relation is just a set of ordered pairs. And we use these kind of curly brackets to indicate that set. So it's just a set or a group of ordered pairs. And then the question asks us to give the domain and the range of G. So again, remember, for domain, I'm talking about the x values. We know in an ordered pair, it's x comma y. So if I want the domain, I want all the first coordinates in each ordered pair. And it's asking me to use set notation. So we're going to use these curly braces. So for the domain, I have in my first ordered pair, my x value is 4. So maybe I'll just label these x's. It's my first coordinate. So my domain is 4, 8, and 5. And 8 we already have, so I'm not going to include that twice. So my domain is just my x values. Now my range, on the other hand, we said is the y values. So these are all of these values. So now in my range, I have 5, 0, m, and n. And that would be my range. Okay, so the second example is just the same question. It gives us a different relation now. And again, it wants the domain and range. So the first thing we can do to help ourselves out, I know the first coordinate in every ordered pair is x, and the second is y. So my domain, I know, has to do with the x values. So in this case, I have 1, 5, 9, and negative 4. And for my range, I have my y values, 0, 5, negative 3, and 1. So that's domain and range. So my domain are my x values, or to use some language we'll be using, our inputs, and our range is our y values, or our outputs. So now let's get back to this idea of whether a relation is actually a function. Okay, so in this part here, it says to decide whether the relation is a function. If it is a function, give the domain and range. And so remember here, I'm going to repeat this. It's a function if every x value has only one y value. That's the only way I'm going to be a function. Every x is matched with only one y. So let's take this first relation. It matches up some inputs with some outputs. And so I'm going to check. Here I have 1, and we can see that 1 is matched with only one output, and that output is 3. So that's okay. 2, again, the input only has one output, which is 3, so we're okay there. 3 is matched to only one output. But now 4, I have a problem, because 4 is matched to 6, and it's matched to 8. So for A, we would say this is not a function. And I'm just going to make a note. It's because the input value of 4 is matched to 2 output values. And so that makes me not a function. Now, in the next one, on the other hand, if I look at B, for each input, it looks like I'm only matched with one output. I don't have any number in my input column that's matched to 2 different outputs. So this one we would say is a function. Now, our domain, and I'm going to use the capital letter D for domain, remember, is our inputs. So my domain is 1, 2, 3, and 4. And my range is my Y value or my outputs. And so I have 1, 5, and 9. So as we move on here, we're going to look at some different ways of displaying these relations and decide whether or not we have a function in each case. So we've got a few examples here. Again, so for number 1, remember our big question. For it to be a function, each domain value or input value can only be matched with one output value. Well, in this case, we can see that our input is actually matched to 4 different outputs. So that clearly is not a function. Okay, so let's take a look at relation 2. So I see I have all of these are unique, and each value in the domain, all my inputs, are only matched with one output. So in this case, we do have a function. Okay. Now, here we go. We have our data in some table form now, and now we have to be a little bit careful. What I'm looking for in my domain, I'm looking to see if I have any of the same input. And so here I notice I have the same input of G. But now what I notice is G is matched to T. So I'm going to, if we were thinking about it this way, I've got G is matched to T, but G is also matched to G. Because that one input has 2 outputs, we are not a function. Okay, in relation 4, same thing. I'm going to look here and see if I have any duplicates in my domain. So here I notice I've got 5 and 5. So I'm going to take a look. For that input 5, what does that match to? So my input of 5 has an output of 7. Here, my input of 5 also has an output of 5. So again, that's going to cause me some trouble. So right away, I know I'm not a function. But what I also happen to notice is the same thing happens with 7 here. I have 7 is matched to a value of 5. It's also matched to a value of 7. So again, because that input has 2 outputs, I cannot be a function. All right, the last way we're going to look at this is if we're just given a set of ordered pairs here. And I'm going to approach this much like I did the table. The first thing I do is I look at my inputs and I see if there's any duplicates. And what I notice is that I have 0 here and I have a 0 here. And so if I'm thinking kind of this mapping here, I notice that 0 goes with -2. It also goes with -1. Again, I have a case where my input has two outputs, so that cannot be a function. Do the same thing here. Again, I'm looking for any duplicate inputs. I notice I have a 9 and a 9 here. And again, 9 is matched to S, and 9 is matched to M. My one input has two outputs, so it cannot be a function. All right, we have one additional way of telling whether a relation is a function, and this is really easy to do if we have a graph. Excuse me. So we say a graph is a function if no vertical line intersects the graph at more than one point. So in this case, you can see here's my vertical line, and it's only going to intersect the graph at this one point. And really, I think of it like this. If I take a straight edge, so I'm going to use this to be my vertical line. No matter where I slide that vertical line, it's only going to touch the graph at one place at a time. So this is a function. Okay, my second one here, again, here's my vertical line. We can see that it only intersects the graph at one point. And again, if I were to take my ruler, my vertical line, and slide it, no matter where I go, I can sketch in a few more of these. No matter where that vertical line is, it always intersects the graph just at one point. So that would also be a function. Now, our next example here, if I look at my vertical line test, I can see pretty quickly that I have an intersection point here and here. Since that vertical line intersects the graph at 2 points, we would say this is not a function. And we have the same situation here. My vertical line is going to intersect, actually, we have 1, 2, 3 points, so we are not a function. So that's what we're going to do practice with right now, just looking at a graph and deciding if it's a function. So for the first one, here, if I take my ruler, actually anywhere along here, if I were to draw in my vertical line, I'm going to intersect at 2 points. So I would say that is not a function. For number 2, now this is really just a set of points, but again, I could pick, if I drew my vertical line here, remember it says if any vertical line intersects at more than 1 point. So if I picked this vertical line, you can see I'm intersecting here and here. So this is also not a function. Now the next one's a little tricky. It seems like if we drew our line through here, that we would be intersecting at 2 different points. However, the function is only defined here. This open circle is actually not a point on that graph, so no matter where I go, I only intersect at 1 point. So this would be a function. Okay, go ahead and pause the video and see if you can determine whether these last 3 examples are functions. And then when you unpause, you can check your work with mine. Okay, so here's what you should have for those last 3 examples. Okay, the last bit of notes for today are just some problems for you to try to make sure that you've got this. So again, if you pause the video, when you unpause it, I'll have all the solutions. And then if you have questions about how I got any of these answers, you could feel free to check in with me. Okay, so go ahead and check your answers. So there's the first set. Obviously in these last two, I have one input matched to two outputs, so those are not functions. And then the last group, we're just using our vertical line test to check whether or not we have a function. So this is day 1 of 4.8, and the next section will be evaluating functions, and then that will be it. Good luck on the homework.